Hi everybody, Mrs. Bolin here, and this is the last video looking at Learning Target 5.3. So we're solving systems of equation by elimination. And in our first video, right away, our equations had either the x's or the y's get eliminated or they canceled and dropped out of our problem. In the second video, we talked about how you may have to multiply one or both equations in order for your x's or your y's to drop out. So in example 3, we said, here you have to multiply one equation. And we did some examples in a U-try where you're multiplying one equation in order for one of your variables to drop out. We have one last example to do, example 6. And example 6 is the toughest because right away we see x's and y's don't cancel, right? They don't drop out of the problem. And there's no way I can just multiply one equation, because I can't do 7 times a number to get 8, and I can't do 2 times a number to get 5. So what I'm actually going to have to do, and I'll make a note here, I'm going to have to multiply both of my equations by a number. So over here, I'm going to make a note that the toughest type of problem here is example 6, because we have to multiply both of our equations. So here I'm multiplying both equations, and I need to pick a number here, and I can choose to cancel my x's or to cancel my y's. And right away I know that both 2 and 5 multiply to 10 pretty easily, right? And so if I wanted my y's to cancel, it would be nice if one of these would be negative 10y and one would be positive 10y. And so I could do that. I could get the top equation to be negative 10y if I multiplied it by 5. And I could get the bottom equation to be positive 10y if I multiplied it by 2. And so I can draw my arrows because I'm going to have to rewrite both equations now. Remember, this is like distributive property. I need to do 5 times each of these terms. So 5 times 8x gives me 40x, 5 times negative 2y gives me negative 10y, and 5 times negative 4 gives me negative 20. Now I'll look at my second equation and I'll multiply every term by 2. So 2 times 7x gives me 14x, 2 times 5y gives me positive 10y, and 2 times 10 gives me 20. Notice here that I have a negative 10y and a positive 10y, which is perfect because when we go to add these equations vertically, negative 10y and positive 10y cancels, or my y's drop out of the problem. So now I can continue treating this as an addition problem. 40x plus 14x gives me 54x. My y's dropped out. Negative 20 plus 20 gives me 0. No big deal that I have 54x equal to 0. I'm still just trying to get x by itself. So to undo 54 times x, I will divide by 54 on both sides. Makes it kind of nice because 0 divided by anything is just 0. So x is 0. I have half of my solution. And now I need to plug x is 0 in for x in one of my original equations. You can choose either. You could pick one of your rewritten equations, but I would avoid doing that because you can see these are much larger numbers, right? Now that we've multiplied the equations by 5 and 2. So I would pick one of the original equations that's printed on your page. I'll just choose the top equation. So I'm going to write 8 parentheses. I won't write the variable x because I'm going to plug in 0 for x. So I have 8 times parentheses minus 2y equals negative 4. So I wrote my top equation, but I left a space to plug in what x is. X is 0. Well, 8 times 0 is just 0. I'm left with negative 2y equals negative 4. My last step to get y by itself is to divide by negative 2. And I get that y equals 2. So now I have my solution, x comma y, or 0 comma 2. All right, so now you have a U-try and you will have to multiply both equations, and you can choose if you want to make your x's cancel or your y's cancel. Sometimes you might see that one way seems easier than the other. So at this time, go ahead, pause the video and see what you come up with. Let's talk about this u-try. So I chose to cancel or eliminate my y's, and the reason I did that is because keep in mind for x's or y's to drop out of the problem, they have to have opposite signs. And I noticed that one of my y's was positive and the other was negative. So I noticed that that would be helpful. If you eliminated your y's, then that means you had to multiply your top equation by 2 so that you would get a positive 6y, and your bottom equation by 3 so that you would get a negative 6y. And then your y's would drop out of the problem and you would get x equals negative 2. You would then plug x equals negative 2 back into one of your original equations for x. I plugged it into the top equation and I got that y equals 6. So my solution was negative 2, 6. I will point out that instead of canceling your y's, you could have canceled your x's. So you could have used your knowledge that 3 and 4 can both easily multiply to give you 12. You would have to be careful though. So if in the top you multiplied by 3 and you did 3 times negative 4x, you would get a negative 12x. That would mean for the second equation, you need to get a positive 12x so that negative 12x and positive 12x would cancel. So in the bottom equation, you would have to multiply by a negative 4, so that negative 4 times negative 3 gives you positive 12. If you didn't notice that right away, then maybe when you were rewriting your equation, you noticed that your x's didn't quite cancel, right? So sometimes you do just have to change the sign of the number that you're multiplying the equation by so that you, in this case, would have negative 12x and positive 12x, which would cancel. Whereas with my y's, since I chose to cancel my y's and they already had opposite signs, it was a little bit easier to multiply by a positive number here, and 6y and negative 6y canceled.